What is Tornado Alley? Tornado Alley is a term used to describe the region of the central United States that experiences more tornadoes than anywhere else on Earth. It is not an official designation with fixed borders, but a general name for the area with the highest tornado frequency. Traditionally, it includes Texas, Oklahoma, Kansas, Nebraska, South Dakota, northern Iowa, and parts of Colorado. The United States as a whole records about 1,200 tornadoes every year, which is more than any other country. Roughly 3/4 of these occur in or near Tornado Alley. The flat terrain, weather patterns, and proximity to moisture sources make this region ideal for the formation of violent storms. Interestingly, meteorologists point out that Tornado Alley is not static. Over the past few decades, studies have shown that tornado activity has shifted somewhat eastward. States like Mississippi, Alabama, and Tennessee, often referred to as Dixie Alley, are now experiencing more frequent and deadly tornadoes. However, the Central Plains remain the most iconic region when people think of tornado outbreaks because of their long history of devastating storms. This shifting pattern highlights how climate and land use changes can influence storm activity, but Tornado Alley continues to be at the center of global tornado discussions. Geography. The perfect tornado laboratory. Geography is one of the biggest reasons why Tornado Alley is so active. The central United States is mostly a vast, flat plain that stretches from the Gulf of Mexico up to Canada. Unlike other parts of the world, no major mountain ranges are running east to west to block or redirect air masses. This allows warm, humid air from the south and cool, dry air from the north and west to collide freely over the same region. To the south lies the Gulf of Mexico, a constant source of warm, moist air. This moisture is critical because it feeds thunderstorms, making them more intense and giving them the fuel needed to grow vertically into the towering clouds often seen in severe weather outbreaks. From the north, cold and often dry air descends from Canada, particularly during spring when winter's lingering cold still affects the upper Midwest. From the west, especially east of the Rocky Mountains, comes hot, dry air from the high plains and desert regions. The Rocky Mountains themselves play an indirect but vital role. As weather systems pass over these mountains, the air on the eastern side tends to descend rapidly, warming and drying out in the process. This helps create boundaries known as dry lines, which often act as a trigger for thunderstorms. The jet stream's role. While surface conditions set the stage, the upper atmosphere provides the mechanism that transforms ordinary thunderstorms into tornado-producing supercells. A key player in this is the jet stream, a fast-flowing river of air located about 30,000 feet above the ground. During the spring, the jet stream typically dips southward across the central United States. This creates a stark contrast between the warm, humid air near the surface and the cooler, drier air aloft. More importantly, it produces wind shear, which means that wind speed and direction change significantly with height. At lower levels, warm, moist air often flows northward from the Gulf of Mexico. A few thousand feet up, the winds may shift direction and blow much faster from the west or southwest. This change in wind speed and direction tilts the rising air from thunderstorms, causing it to begin spinning horizontally. When strong updrafts in the storm tilt this horizontal rotation into a vertical orientation, it creates a rotating thunderstorm called a supercell. The presence of the jet stream also helps to ventilate the storm, allowing it to maintain strong updrafts and continue feeding off surface moisture. Timing and tornado season tornadoes can form at any time of the year, but in Tornado Alley, the peak season is from April through June. This period corresponds to the transition from winter to summer, when the clash between different air masses is at its most intense. By spring, the land across the plains has warmed up, allowing warm air near the surface to rise quickly. At the same time, the jet stream is still dipping far enough south to keep upper-level winds strong and cold air lingering to the north. This sets up a powerful collision between air masses of very different temperatures and moisture levels. Timing varies slightly across the region. Southern areas like Texas and Oklahoma often see their highest tornado activity in May, when warm, moist air from the Gulf surges northward and meets lingering cool air. Farther north, in places like Nebraska and the Dakotas, peak activity often shifts into June as the jet stream retreats northward with the season. These seasonal shifts explain why Tornado Alley's severe weather seems to migrate northward as the months progress. By late summer, tornado frequency often decreases in the Central Plains, but may increase in parts of the Midwest or Southeast. How supercells create tornadoes. Most significant tornadoes in Tornado Alley come from supercell thunderstorms, which are rotating, long-lived storms capable of producing large hail, damaging winds, and sometimes multiple tornadoes. The process begins when warm, moist air at the surface rises and encounters cooler air above. This creates a strong updraft that feeds the storm. If there is enough wind shear, this rising air starts to rotate horizontally. The storm's powerful updraft then tilts this horizontal rotation into a vertical column, establishing a rotating core known as a mesocyclone. The mesocyclone is the heart of the supercell. Under the right conditions, particularly when the lower atmosphere is moist and unstable, the rotation intensifies and narrows, eventually extending downward as a visible funnel cloud. If this funnel cloud reaches the ground, it becomes a tornado. A useful analogy is that of an ice skater spinning. As the skater pulls their arms closer to their body, the spin speeds up. Similarly, as the column of rotating air narrows, it spins faster, creating a tornado with intense winds. Human factors and urban impact. While nature creates the storms, human presence shapes how devastating they can be. Tornado Alley has historically been sparsely populated with farms and small towns. However, in recent decades, urban centers such as Oklahoma City, Dallas-Fort Worth, and Kansas City have grown significantly, placing more people and infrastructure in harm's way. As cities expand into areas that experience frequent severe weather, the potential for large-scale destruction and casualties increases. Even with modern technology, tornadoes can form quickly and sometimes strike with limited warning, making densely populated regions especially vulnerable. Advances in Doppler radar, satellite monitoring, and early warning systems have saved countless lives by providing better lead times for evacuation and shelter. Despite these improvements, the unpredictable nature of tornadoes means the threat remains high. Is Tornado Alley shifting? In recent years, researchers have noticed that the highest concentration of tornado activity appears to be shifting slightly eastward, away from the traditional plains and toward the lower Mississippi Valley. This area, dubbed Dixie Alley, includes parts of Mississippi, Alabama, and Tennessee. Several factors may be contributing to this shift. Some scientists point to natural climate variability and changing atmospheric circulation patterns. Others suggest that land use changes, such as agriculture and urban development, may influence local weather dynamics. Regardless of the exact causes, the shift underscores the importance of preparedness across a wider region. While the Central Plains continue to experience some of the strongest and most frequent tornadoes, communities in the Southeast are increasingly at risk. These areas often face additional challenges, such as higher population density and more nighttime tornadoes, which can be especially deadly because they catch people off guard.